Yeah, testing 1 2 1 2. There's a little something for you. You love.
Watch my 9mm go bang. Why da dang? Why da dang? Watch my 9mm go bang. Why da dang? Why da dang?
Eigenvalues and eigenvectors. Why do you need to be so elusive?
Wait, isn't that Amirul? What's he doing here? Hey Amirul, let's go eat at Chengal.
Not right now, Dary, because I still suck at these eigenvalues and eigenvectors. This eigen everything is driving me crazy.
Is it that hard? Then let me teach you then.
Alright, first thing first. We need to think of eigenvalues as the magic numbers that don't change direction under a transformation. They tell us how much a metric scales our species face.
And eigenvectors?
Well, eigenvectors are like the arrows that may stretch or shrink, but they still point in the same direction. They show us the directions in space that remain unchanged after a transformation.
Okay, that makes sense. But how do I find them?
Well, let's break it down step by step. Firstly, we need to find
Dary, why are we in digital form?
Well, this is the easiest way to convey information, so I just called for some help. Teacher and Nazirul is here to help us understand more about this stuff.
Ah, I see. Now this is helpful.
Hello guys, so what are we trying to teach today?
You must help me to understand about these eigenvalues and eigenvectors.
It's okay, we can help you with that. Let me explain first.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazirul Hakim bin Muhammad Azain. Today I want to explain about how to find the eigenvector. Before that, we have to find the eigenvalue. To find the eigenvalue, we can use this formula Ax equal to lambda x. A is stands for square matrix, and then x is eigenvector, lambda is eigenvalue. After we know all that, firstly subtract this term both sides. After we subtract it, we can get this formula Ax minus lambda x equal to 0. After that, we have to insert identify matrix between the lambda and x. Identify matrix is I. After that, factor out the vector. We put x outside this a and lambda I, and then we can get this formula after factor out the vector. And then this actually the characteristic polynomial. After we got all that, solution to this equation will be our eigenvalue. So we can find the eigenvalue and then we do to find the eigenvector.
Okay, let's move on to the next part, finding each eigenvectors. Using the formula derived from before, the V represents the eigenvectors. Because we have different values of lambda, the eigenvectors also differs. To find eigenvectors, we will use ERO. After we find the REM, then we can assume one of the variables to be unknown. Alright, let's take a look at an example. Okay, here we have a 2 by 2 matrix with its corresponding eigenvalues. So for each lambda, we have different eigenvectors. Therefore, we need to find each of them. We can insert our lambda into the formula given, and with the corresponding matrix, we got the answer. From the matrix that we got, we can compare it to our original formula. And then from this part, we can use ERO to find the REM. And then the REM will be used to find the eigenvectors. To find the eigenvectors, we must assume one of the variables as a free variable. For this example, the free variable that we use is x2. We can let x2 as k, and then from the matrix we can compare and insert the k in the equation, and then we got this. Then from there we can assume the number of k either all real numbers. For this example, the k we use is equal to 2 because it's the easiest number to do. Then substitute the value of k into the equation that we got, and then we got the eigenvector for this lambda.
I think I got it now, Che. Now let me do the lambda negative 1. By subtracting negative 1 times identity from the main diagonal, I find the result is 2142. By using elementary row operation, which is negative 2r1 plus r2, I got the new second row, which is 2100. Now I let the x2 as the free variable, and then I let x2 is equal to k. From the new equation, from the first row, I got 2x1 plus x2 is equal to 0. So from that, I get 2x1 is equal to k. Oh, I'm sorry, my bad. Okay, let x2 as the free variable. So when I let x2 is equal to k, 2x1 plus x2, when I change x2 is equal to k, so I get 2x1 is equal to negative k. So 2x1 minus negative k, so negative k over 2. So when I let k equal to negative 2, and 2x1 is equal to negative 2, and I got x1 is equal to negative 1. So the eigenvector for this is negative 1, 2.
Now we can start doing a more tricky question. This one is not like before. This one is a 3-3 matrix. Yes. So given this one, this A is 1, 0, 0, 3, negative 2, 0, 2, 3, 4. So just like before, you can use this one, this particular formula, and then you just fill in the A and this what do you call this? Lambda multiplied by identity. Yes, identity, this one. So that's how you get these. And then from doing that, you just minus everything, and then you get this one. Then after that, you just simply simplify it. Simply simplify, huh? And then you'll get lambda 1, lambda negative 2, and lambda 4. Then from that, let's just start with lambda 1, shall we? Following this formula, right? So this lambda here, we just fill in this lambda 1 inside of this lambda, right? Okay. So this lambda is 1, all right? Then we put this 1 lambda inside the lambda here, okay? And then we just multiply the identity with this 1, right? That's why there's nothing here. And then from that, you can get this thing, this one, 0, 0, 0, 3, negative 3, 0, 2, 3, 3. And from this form, we can transform it into this kind of form. This is because you can easily find something like x1, like this, right? We can make multiple equations, right? 2 equations to be precise. So from this form, we can make something like 3x1 minus 3x2 equal to 0. And then this other one is 2x1 plus 3x2 plus 3x3 equal to 0. So the only thing now is this one. This one is 0, right? So we don't need to write anything, I guess. So this row is literally nothing, right? We can let this x1 to be a free variable. So first thing first, we let x1 equal to k, right? So we'll just take this one. This one is the most simplest equation there is for this form, right? So we take this particular equation, and then we just put k in it. This one, I just take this one to here, and it becomes negative, right? So I just change x1 into k. So since, okay, when after that, I just eliminate this one, so it equals to x2 equals to k, right? But since this one is also equals to k, so I just write it like this, right? Then from this one, I can just take this equation, right? And then I'll just put this k inside here, x1 and x2. I'll just put it inside of this equation. So from that, I could get x3 equals to negative 5k divided by 3. So that's settled. And then we'll just put it back into this form. So we know that x1 equals to k, right? Then x2 equal to k, x3 from this one we put it in here. We already know, right? So we just need to assume. So maybe I'll say k is equal to 3, right? Because if I make k equal to 3, I could just eliminate this one, and then I'll get negative 5 only. So since the k is equal to 3, I can just put this one equal k. This one turns into 3 as well. So the v1 should be 3, 3, negative 5. All right, you got that, buddy? Continue our discussion, shall we? So
The other lambda is lambda negative 2, right? So just like before, you put this negative 2 inside of this formula, the a minus lambda times by identity. Yes, so you already know this part, right? So I'll just write the answer right here. So from this matrix, you can write it into this form, just like the other lambda before, right? So you just write it like this, and then from the equation you can see that the first row, you know that x equals to 0, right? And the second row, no, the first row, from the first row, you know that this 3x1 equals to 0, right? So if you bring this 3 into 0, you'll get x equal to 0. Am I right? And then since the second row is just the same as the first row, so it'll be the same equation, x equal to 0. So the only different equation is the third one, 2x1 plus 3x2 plus 6x3 equals to 0. Okay, and then since we already know x1 is equal to 0, you just put it inside here, and then you just turn it to 0. Yeah, and then after that, you just put this 3x2 into here, and then it'll become negative, and you just eliminate each other, and then you get x2 equals to negative 2x3, right? So from here, let's just assume x3 equals to k, right? So from that, we'll just get what, x2 equal to 2k. Just put k inside here. Then after that, to find x3, this x3, let's just assume k equals to 1, shall we? And then from this equation right here, I'll just add 1 into the k. So from here, we'll get negative 2 as well, right? x2 equals to negative 2. Okay, and then since x3, we already let x3 equal to k, and then k is equals to 1, we already assumed that, right? So that means x3 equals to 1. Then from there, you just put all of these random numbers and then put it inside here. So we'll get the answer for the vector. Alright, easy, isn't it?
I think I got it now, Dary. Let me do the last part. This requires us to subtract the 4 times identity from the main diagonal. So after that, I got negative 3, 0, 0, 3, negative 6, 0, and 2, 3, 0. So the first row tells us that negative 3x1 is equal to 0. So x1 equal to 0. The second row tells us that 3x1 minus 6x2 is equal to 0. We can change the x1 from the first row, which is 0. So 3 times 0 minus 6x2 equal to 0. So after completing it, we get x2 is equal to 0. The third row, we get 2x1 plus 3x2 is equal to 0. So by changing x1 and x2 both with 0, so we get 0 is equal to 0. So we can assume that x3 is a free variable. Because we don't have many information, so we can just assume that x3 is equal to 1. So we can write the eigenvectors with 0, 0, 1.
Okay, next, after we know the eigenvalue for this example, our eigenvalue is 1, 2, and 3. We can use this formula, AV equal to lambda V, and then we have to put the identified matrix as R. And we subtract both terms, and then we got this, which is 0 equal to lambda IV minus AV. Next, which is the last step, we factor out the V, and then we get lambda I minus AV equal to 0. After we know the formula, we can use to find the eigenvector. For this example, we already have the lambda I minus A, which is here, and then we have to do one by one, this one, and this one. But for this example, I do for the lambda 1. We just have to substitute lambda 1 in the equation, which is lambda minus 1 is 0, minus 1, this one we only have to copy because this we don't have the lambda. So negative 1, negative 2, 0, lambda minus 2 is negative 1, negative 2, 1, negative 1, lambda minus 3 is negative 2, and then we assume here is x1, x2, and x3. Here is 0, 0, 0. Next, after we done this, we can do the ERO. For the ERO, we just copy this, which is 0, negative 1, negative 2, 0, negative 1, negative 2, 1, negative 1, negative 2, 0, 0, 0. Okay. For this one, we can see that this row 3 and row 1 should be exchanged. So we change R1 with R3. So we get 1, negative 1, negative 2, 0, 0, 0. And then we just copy the row 2 because it's not changed anything. 0, negative 1, negative 2. After that, we want to make this negative 1 as positive. because our target is 0, 1, 0, 0, 0, 1, 0. So here is positive. So we change it by multiply with negative R2. So row 1 and row 3 does not change anything. So we just copy 0, 0, 0, 0, negative 1, negative 2. So we only change here as positive, positive. And then we can proceed with the ERO until we get the final, which is REM and RREM. Then we can do as R2 plus R3. We want to make this as 0, the entry. So we get 1, negative 1, copy the same thing, 0, 1, 2, 0, 0, 0. We get the REM, and then we still proceed with the same ERO to find the RREM. To find the RREM, we make this as 0. So what we have to do? We have to use the leading one from R2. So we do R2 plus R1. So we can get 1, 0, 0, 0, 1, 2, 0, 0, 0, 0, 0, 0. Okay, so we're done for the RREM. Next, we look for the raw A. Raw A is 1, 2. So have 2. Same with the raw AB. For the number of nodes, we have x1, x2, x3, which is here. So the number of unknowns is 3, and we can conclude that this is mini solution. Then we can proceed. We choose the free variable. We choose x3 because x3 don't have a leading one. So we let x3 equal to k. We just see that for the x1 is x1 equal to 0. x1 equal to 0, and x2 for this one we can get x2 plus 2x3 equal to 0. So x2 plus 2x3 equal to 0. Then we can find the x2, which is negative 2x3 equal to negative 2k. And then for the last answer, we can get as x, x1, x2, x3. And then we just put the value of each x1, x2 and x3, which is the x1 is 0, the x2 is 2x3, and then we already sub the x3, which is k. So we get negative 2k. And then for the x3 is k because we already assumed that x3 is k. So the last step, we just have to assume the value of k. We just assume as 1, so it's more easier to calculate the last answer. So k is 1, and we got the answer is 0, negative 2, 1. So the last answer we can write as v, which is the eigenvector. 0, negative 2, 1 is eigenvector corresponding to eigenvalue lambda equal to 1. And we got the final answer for the lambda 1, and then we repeat again the same step with the eigenvalue with different, which is 2 and 3.
Phew! Finally done.
Now, it's easy, right?
Yes, easy like ABC.
Yes. Do you know what that means?
What?
We can finally eat at Chang'an.